our simulation tool is simulating this small drone with a certain amount of range sensors, upwards, downwards, left, right, front, and back. Actually, in the simulation tool, you have 4 extra sensors going in diagonal of 45 degrees. So not just front and right, but in between the front and right, you have 45 degrees and all the four subdirections. So let's see the simulation. I could start it. So you see those rangers, those 4 dots moving. The main challenge in this section, actually, a major challenge in the entire course is to design a control algorithm that take those few sensor information, meaning the ranging in front and right, back, downwards, and so on. Maybe blend them or fuse them with the IMU information, and to decide what to do with the drone. Recall that the drone can hover, can go upwards, downwards, left, right or left, front or back, and perform yaw. Consider, for example, that it want to maintain a certain distance from a wall, say half a meter, and let's say this is a half a meter. Now it's too close. It could perform the following maneuver, or just perform a yaw, and then going forward, it will slowly increase its distance. So in a way, the challenge is not just how to control your height, but in terms of a certain distance from a wall, you may think that you have 2 options, actually more than that, but 2 main options of how to perform the control algorithm. You can do it either on the roll or on the yaw, assuming going up, front or back. So when designing a control algorithm to avoid obstacles or to follow a certain distance from a wall, you need to define in a proper way how you're going to do that. In terms of, should I control the roll? Maybe for emergency distance, that will be most efficient, but maybe for more smooth moving, controlling my yaw will be the right way to go.